In the last video, we talked about how the product rule takes something like p of x, which is actually two separate functions multiplied. An example of that, we'll just put one here. Like, let's say we have a 5x squared times an e to the x. We found that you cannot just take this part and find 10x and this part e to the x and get the correct answer, because these are not simply added. They are multiplied. These are functions that are combined in a different way. And you can't just use the basic rules that we've learned by itself. So in the product rule, we found that p prime was equal to, and you know what, let's go ahead and call these what they are. I'm going to name this function u, and I'm going to name this function v. And let's say this is to the negative x, just for fun, just so it's a little different. Okay, so my u function is 5x squared, and my v function is e to the negative x. U prime would be 10x, and v prime would be negative e to the negative x, because you need that negative sign to come down with our e to the x rule. So if these were just multiplied like this, u prime would be 10x, and v would be e to the negative x, plus v prime, negative e to the negative x, times u, 5x squared. And if I want to put these together, well, I have an e to the negative x on the outside, so that's nice. We could write it as e to the negative x. I didn't do that on purpose, but it highlights it well. Minus 5x squared. Right? You got to keep that in there. So this would be our product rule answer. But what I'm going to do now is I'm going to take the same function and I'm going to try and use a different rule. I'm going to take 5x squared and I'm going to write over e to the x, because e to the negative x, it means basically you can bring it down into the denominator as a positive exponent. And the quotient rule says that p prime is equal to u prime v minus v prime u over v squared. So we're still going to take these separate constituent components here, but we need to write them down and make sure that they're in the same way as they appear in our problem. So it's similar but different, right? First we want u is 5x squared. U prime is still going to be 10x. V is e to the positive x, different from the product rule example before. And v prime will just be regular e to the x. So if I want to play with this, we're just literally going to plug it in. U prime v, okay, so 10x times e to the x minus v prime e to the x times u, 5x squared. And all that will be divided by v squared, which is e to the x squared. Okay. Now, how do we separate this? Well, there is an e to the x in everything. So we can say 10x minus 5x squared, and all of that is divided by e to the x. And you may notice that in our product rule version, I could have brought this underneath and wrote it as over e to the positive x, and that would be the same answer as this. So what I'm trying to show you is that in the product rule versus the quotient rule, they're two sides of the same coin with algebra between them. Okay, in the product rule, if you have p is equal to two multiplied functions, which is going to happen a lot, then p prime, and you know what? We want to use u times v, just to be very clear what our first and second terms are. P prime is u prime v plus v prime u. Okay, u prime v plus v prime u. That's the product rule. Doobie-doobie-doo. Something. The quotient rule, very close, but different. This is u divided by v. These are both functions of x. It's f of x divided by g of x. Okay, we just don't want to write all that out, so we're just going to call them u and v. You need to remember that. P prime, same order. Okay, I'm writing the same order, u prime v, but it's minus v prime u. And then we're going to divide by v squared. This is the original v. This is the original v. V prime shows up only once. U prime and u show up, okay? So if you remember these formulae and appreciate that they are two sides of the same coin when you go through the derivation, which none of us enjoy doing, and is available to you already online, these are the rules that you need to learn. Now let's just go into the practice problems and crank them out, and I think you'll get comfortable with it by practice more than by reading the abstract math here.